Good morning, guys. Hope everybody is doing well. I just wanted to say how proud of you all I am and how much I miss you, and hopefully I'll see you guys soon. But for today, another day of online learning, and we are going to move into 10.3 arcs and chords. So our first theorem says, in the same circle, or in congruent circles, two minor arcs are congruent. So remember, minor arcs are less than 180. If and only if their corresponding chords are congruent. So remember, if and only if works both ways. So what this is saying is, for example, if we have arc FG, if we know that arc FG is congruent to arc JH, then we know that their chords, their corresponding chords, must also be congruent to one another. This works both ways. So this means that if we know the chords are congruent, then we can also say the arcs are congruent as well. So of course, let's do an example and let's use this. It says a circular piece of jade is hung from a chain by two wires wrapped around the stone. They then tell us that chord JM is congruent to chord KL, and they actually marked it on the picture for us. They then tell us that the measure of arc KL is 90 degrees. Then what is the measure of arc JM? So by the previous theorem, if the chords are congruent, the corresponding arcs are congruent. So if our one arc KL is 90 degrees, that means the measure of arc JM is also 90 degrees. Okay, pretty simple theorem to start us out. Now let's see what else. Example 2 says, in the figure, circle A is congruent to circle B. So in the last one, the chords and the arcs are on the same circle, but if you go back to the theorem, it says in the same circle or in congruent circles. So now the circles are congruent, and they tell us that the two arcs are congruent. If the two arcs are congruent and the circles are congruent, we want to then find the chord. Well, we know that if the two arcs are congruent, the chords are therefore congruent. So we know that WX, chord WX is congruent to chord YZ or ZY. So what can we do? We can then set them equal. 7x minus 2 is equal to 5x plus 6. I'll solve this by subtracting 5x over and adding 2 to the other side, so x is going to equal 4. But we are not finding x. If you look at the problem, we are finding wx. So wx is going to be equal to, in this case, 7 times 4 minus 2. So wx will equal 26. And now it didn't matter here if you plugged into wx or yz, because they were both equal, you should still get 26. That's a good way to check yourself. Okay? Okay, let's move on. And as always, guys, if you look at the worked out notes that I added, the blank notes and the worked out notes, there are you try problems. So I do not go over the you try problems in the video. They're on the worked out notes. So if you wanted to go and try them yourself and see how you do, use the blank notes and the worked out notes, and then you can ask me any questions. That'll be a good way to see if you understand it as we go forward. Okay, so a few more theorems. Theorem 10.3 says is if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. 10.4 is the opposite. It says if the perpendicular bisector of a chord is a diameter of the circle. So these are opposites of one another, but if we read 10.3, it says if a diameter or radius is perpendicular to a chord, then it bisects the chord and the arc. 10.4 says, so if it's perpendicular, then that means that we know that those two pieces of chord are congruent and the arcs are congruent. 10.4 says the opposite. The perpendicular bisector of a chord, then we know it has to be a diameter or a radius. So AB would have to be a diameter or CB would have to be a radius. And let's use it. Our next example says, in circle S, the measure of arc PR is 98. So I'm going to label that. So the whole thing is 98, our whole arc that I just outlined in red, PR. It then says find the measure of arc PQ and find the measure of PR, which happens to be the chord. So here's what we know based on the prior theorem. We know that by theorem 10.3, if a diameter or radius is perpendicular, then it bisects. So we see that our radius QS is perpendicular to our chord, which means that it's going to bisect our chord and bisect our arc. So what does this tell us? If the whole arc is 98, each piece of the arc is going to be 49 degrees. If the whole chord, if one of the pieces of the chord is 6, the other piece has to be 6. So let's look at what we're trying to find. We're trying to find the measure of arc PQ, which we already said was half of 98, so 49 degrees. And then we want to find the measure of PR. So PR is the whole chord. Well, if one of the pieces is 6, the other piece is 6 because it's bisected, PR is equal to 6 plus 6, which is 12. So using that theorem, if a radius is perpendicular, then we know it bisects the chord and the corresponding arc. Okay, another example. It's kind of a word problem. So example 4 says, in the stained glass window, diameter GH, so we have a diameter, which is GH. We can see it's a diameter, and I'll use a different color so you can see it. We can see it's a diameter because it goes through the center J. It says diameter GH is 30 inches long. So my entire diameter is 30 inches long. So what I'm going to do here is I'm gonna draw this picture to the side so we can actually see what's going on. So we have point G, we have J in the middle, we have our chord, KM, that piece is H, and then we have L, and we have a perpendicular, which kind of hints to the fact that we're going to use the last theorem that we learned, or the last two. So our diameter is, diameter GH is 30 inches long. So if the diameter is 30, I think if I asked you guys, what's the radius? You would tell me 15. It's half of that. So something to keep in mind. The chord, KM, is 22 inches long. So the whole chord, KM, that I just outlined in teal, is 22 inches long. So let's stop for a second, and let's say, what do we know? Well, first off, we want to find JL. So we want to find JL, which I will call X, okay? What do we know? We know that the radius, or the diameter, GH, is 30, but it's also perpendicular to my chord. Judging by the last theorem, that tells me that those two pieces, KL is congruent to LM, the chord is bisected, and the arcs are congruent. Okay? So what else do we know? We know that KM is 22 inches long, which tells me each piece is 11. Right? If they're congruent, each piece is half of 22, or 11. So, let's see what else I know. They tell me that the diameter is 30. That has to be useful. So how can that come in handy? It's actually, when you think about the diameter being 30, we know the radius is 15. You can draw a radius anywhere from the center to any point on the circle. So if I want to find X, I know that JM is actually a radius. So JM is 15. So what I'm going to do is I'm going to tell you how to find X. We're actually we have a right triangle. We want to find JL. So JL is that piece right there. That is X. That's what we're looking for. We know that the bottom, LM, is 11 because it's half of 22. And we know that the radius of the circle is 15 and JM is a radius. So we now have a right triangle where, if we have a right triangle, how do we find one side? We'll use Pythagorean theorem. So x squared plus 11 squared equals 15 squared. If you do this, X squared equals 104. So X or JL is going to equal 10.2. Okay, definitely a more challenging problem on here. Okay, so if we go back through this again, let's think about it. We're trying to find JL, that is X. We know that these two chords are congruent because the radius is perpendicular, so each piece is 11. We know our radius, JM, is 15. So we get a right triangle, and JLM, where we have one side is X, what we're trying to find, one is 11, and one is 15, and we can use a right triangle to solve. Okay? It's a pretty good problem using the last theorems and kind of combining everything with Pythagorean theorem. And theorem 10.5. I believe this is our last theorem we are looking at today. Theorem 10.5 says, in the same circle, or in congruent circles, two chords are congruent if and only if they're equidistant from the center. So what does this mean? So we have a circle, we have a center, and then we have two chords. It can be in congruent circles too. These chords are congruent if and only if they are the same, they're equidistant from the center. So they are the same distance from the center. And the distance from the center is always going to be, the closest distance is always going to be perpendicular. That's why you see those. But the key here is that the chords are going to be congruent when they're the same distance from the center. And since it's if and only if, it goes both ways. So, you know so not only are the chords congruent at the same distance from the center, but you know if the chords are congruent that the distance to the center is the same. Okay, so it goes both ways here. Okay, and our last example we're going to talk about today, of course, uses that last theorem. They tell us that EF is equal to GH is equal to 24. So they're telling you that the chords are congruent, which means then that they are the same distance from the center. So if the chords are congruent, we know that QP is congruent to PR. So how can we solve them? Well, of course, we can set them equal. 4x minus 3 is equal to 2x plus 3. I'll solve, subtract 2x. I get 2x is equal to, add 3, 6. So x is equal to 3. And then from here, they're asking us for PQ. So to find PQ, I'm just going to plug back in. 4 times x minus 3. So it would be 4 times 3 minus 3. So PQ is just equal to 9. So if you notice, a lot of the calculations here are not very difficult, but we do have a lot of theorems. So I suggest in these sections, especially when we get, to your quiz and things, you might want to write down these theorems or, keep your notes handy with you so that you are going through these, because we're just going to add more theorems as we go on. Good job today. Remember, go try the U-Try problems yourself and ask me any questions, but you can see the worked out notes with the U-Try problems worked out on Google Classroom. Make sure you're staying up to date, doing your lesson checks, and then your homeworks the next day, checking those, asking me any questions. Of course, I can miss things. If you got things wrong, I might miss it on your homework, so make sure you're asking me when you need help. Keep up the good work, guys.